Hi guys, welcome back to YouTube channel Chemistry Live UGPG. Today we are going to talk about Vsepr theory and shape of some ions. So this will be highly beneficial for BSc Chemistry students under CBCS syllabus. So I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime and help to learn others. So this is the syllabus for Core 1 paper, Unit 4, Chemical Bonding. So let's discuss the Vsepr theory for predicting the shape of some ions like I3 minus, Brf2 plus, PCl6 minus, ICl2 minus, ICl4 minus, NH4 plus, PO4 3 minus and SO4 2 minus. So let's discuss the geometry of some ions. So the geometry of some ion is determined by following two factors. The number of sigma bonds, that is bond pairs, is involved in bonding of the atoms, and the number of lone pairs present around the central atom, and the double bonds, if any, involved in the formation of an ion do not influence the geometry of ion. So that is, the pi bonds are invariably excluded from hybridization. So pi bonds do not determine the geometry of the ion. So let's discuss the shape of I3 minus based upon Vsepr theory. So I3 minus we can get from I2 plus I minus, so giving rise to I3 minus, triiodide ion. So iodine is in group 17 and have 7 valence electrons. So atomic number is 53, I53. So valence shell configuration is 5s2 5p5. And I minus, so obviously it will be 54. So valence shell configuration will be 5s2 5p6. So this is the iodine atom. So where you can have 5s2 and 5p5 configuration. So 5s2 5p5. And this is I minus atom. So here you can have 5s2 and 5p6. And this is the central iodine atom. So where you can have configuration 5s2 and 5p5. So and here the outer shell orbital is 5d orbital is vacant. So this 5p unpaired electron can form bond with the 5p unpaired electron of another I atom, giving rise to I2 molecule, that is sigma bond. Similarly, this I minus atom, one lone pair can donate its pair of electron to the vacant 5d orbital of the central I atom, so giving rise to I3 minus. So now if you count the number of total electron pairs will be 1, 2, 3, 4 and 5. So out of them one is sigma bond and another is coordinate bond or dative bond, and 3 of them are lone pairs. So now I3 minus has 10 electrons at the central iodine atom. So 5 electron pairs, so 3 of them lone pairs and 2 bond pairs. So that is one covalent bond and another is coordinate bond. So the structure should be trigonal bipyramid. So as per Vsepr theory, to minimize the repulsion, so lone pairs will occupy the equatorial position. So this is the structure of I3 minus. So it is linear shape and bond angle is 180. So now let's discuss the shape of PCl6 minus. So PCl6 minus means phosphorus is the central atom and it is bonded to 5 chlorine atoms and 1 chloride ion, Cl minus ion. So phosphorus atomic number 15. So the valence shell configuration will be 3s2 3p3. And phosphorus in excited state will be 3s1 3p3 and 3d1. And chlorine atomic number 17. So 3s2 3p5. So you have one unpaired electron here in chlorine. And in case of a Cl minus, so it will be 18. So 3s2 3p6. So it is all the orbitals are fulfilled. So here we have 5 chlorine atoms, which has one unpaired electron, and this Cl minus has a pair of electron. And the phosphorus central atom, this is the configuration in excited state, 3s1 3p3 and 3d1. So we have 5 unpaired electron in the central atom phosphorus, so that can form bond with 5 Cl atoms, giving rise to PCl5. and this Cl minus, that lone pair, can form bond or donated pair of electron to the vacant 3d orbital, forming dative bond or coordinate bond, so giving rise to PCl6 minus. So that PCl6 minus has 1, 2, 3, 4, 5. So 5 bond pairs and sixth one is a coordinate bond. So the structure PCl5 6 minus has 5 covalent bond and 1 dative bond with Cl minus ion. So hence total 6 electron pairs. So the structure is octahedral. So this is the structure of PCl6 minus octahedral structure. So let's discuss the shape of SO4 2 minus. So sulfate ion. So here the central atom is sulfur and atomic number is 16. And the valence shell configuration is 3s2 3p4, and in excited state the configuration will be 3s1 3p3 and 3d2. Similarly oxygen atomic number 8, so valence shell configuration is 2s2 2p4, and O minus ion, so it will have 9 electrons, so the configuration is 2s2 2p5. So in oxygen atom, neutral atom, so we have 2 unpaired electron, and oxygen anion O minus have 1 unpaired electron. So here this is the central atom in excited state 3s1, 3p3 and 3d2, and this is O minus ion, only have 1 unpaired electron, and this is another O minus ion, 1 unpaired electron. This is one oxygen atom having 2 unpaired electron, and this is another oxygen atom having 2 unpaired electron. So these unpaired electron can form sigma bond. Similarly this unpaired electron overlap giving rise to sigma bond, this unpaired electron giving rise to sigma bond, and here this oxygen O minus can form also sigma bond. Sorry, this will give rise to d pi p pi bond, and here also this form d pi p pi bond, and this one will form sigma bond. So as a result in SO4 2 minus you have 4 sigma bonds and we have 2 pi bonds. So these 2 pi bonds that do not participate for giving rise to the structure. So hence it has 4 bond pairs and 0 lone pairs. So the sp3 hybridization and the structure is tetrahedral. So let's talk about the shape of BrF2 plus. So Br is the bromine, is the central atom, and it is bonded to one fluorine atom and one F plus atom. So bromine atom number 35. So valence shell configuration is 4s2 4p5. So here one unpaired electron, and fluorine 9. So valence shell configuration is 2s2 2p5, one unpaired electron, and F plus, and it has a vacant orbital. So Br is the central atom, so 4s2 4p5, so one unpaired electron, and fluorine atom has also one unpaired electron, so they can overlap giving rise to a covalent bond. Similarly A plus ion has a vacant orbital, so 1 4p lone pair of 4p orbital can donate its pair of electron giving rise to dative bond. So in BrF2 plus, Br central atom has one covalent bond and one dative bond with A plus ion, and 2 lone pairs as well present. So in total BrF2 plus has 4 electron pairs. So the structure should be tetrahedral, but to minimize the repulsion according to Vsepr theory, so it has a linear structure BrF2 plus. So let's talk about shape of ammonium ion. So here nitrogen is the central atom and it is bonded to 3 hydrogen atom and 1 H plus ion. So nitrogen atomic number 7, so valence shell configuration is 2s2 2p3, and hydrogen is 1s1 and H plus is hydrogen, H plus ion has 1s0. So now the central atom has configuration 2s2 2p3. So now these unpaired electrons form 3 covalent bond with 3 hydrogen atoms, and this 2s electron will donate its pair of electron to the H plus ion which has a vacant orbital. So here you have a dative bond. So as a result we have 4 electron pairs So 3 bond pairs and 1 dative bond. So thus the structure of ammonium ion has 3 covalent bond and 1 dative bond. So in total we have 4 electron pairs. So hence the structure is tetrahedral, bond angle 109. So let's talk about shape of ICl2 minus. So ICl2 minus we get by combining ICl plus Cl minus, giving rise to ICl2 minus. So iodine is the central atom with atomic number 53. So iodine 53 valence shell configuration is 5s to 5p5, and chlorine atomic number 17. So valence shell configuration is 3s to 3p5. So 1 unpaired electron. And Cl minus is 18. So valence shell configuration is 3s to 3p6. So we have all the orbitals are filled up with a pair of electron. So here is the iodine central atom 5s, 5p5 and 5d orbital is vacant. So this unpaired electron of iodine can form with one Cl atom giving rise to ICl bond. And similarly Cl minus has all vacant, all filled orbitals. So this lone pair electron can donate its pair of electron to the vacant 5d orbital of iodine, giving rise to ICl2 minus. So the structure of ICl2 minus has one covalent bond and one dative bond. So looking at the central atom, ICl2 minus has 5 electron pairs. So here 3 lone pairs and 2 bond pairs. One of them is covalent bond, another is dative bond. So as per Vsepr theory, the structure should be trigonal bipyramid with 3 positions occupied by lone pairs. So this is the structure ICl2 minus. So hence it is linear structure and bond angle is 180. So let's talk about shape of ICl4 minus. So here iodine is the central atom and it is bonded to 3 Cl atoms and 1 Cl minus ion. So iodine 53 valence shell configuration is 5s to 5p5, and iodine in excited state it will be 5s to 5p4 and 5d1. Similarly chlorine 17 valence shell configuration is 3s to 3p5, so 1 unpaired electron, and Cl minus 3s to 3p6, so all the orbitals are filled up with pair of electrons. So here iodine is the central atom and configuration is 5s to 5p4 and 5d1. So here these two 5p unpaired electron can form bond with 2 Cl atoms, and one 5d unpaired electron can form bond with another Cl atom, and Cl ion has a pair of electron, so that pair of electron can donate to the 5d orbital forming dative bond. So the structure of ICl4 minus has 3 covalent bond and 1 dative bond and 2 lone pairs. So these two are lone pairs. So hence in total 6 electron pairs. So the structure should be octahedral. So as per Vsepr theory, to minimize the repulsion, so ICl4 minus has a square planar geometry where 2 lone pairs will occupy to the opposite vertices. So these are the 2 lone pairs. So hence it has ICl4 minus has a square planar geometry. So let's talk about the shape of PO4 3 minus. So phosphorus is the central atom and it is bonded to 3 O minus and 1 oxygen neutral atom. So phosphorus atomic number 15, so valence shell configuration is 3s to 3p3, and oxygen 8 valence shell configuration is 2s to 2p4. So here you have 2 unpaired electrons, and O minus has 2s to 2p5. So you have only 1 unpaired electron, and phosphorus 15 in excited state it will be 3s to 3p3 and 5d1. So phosphorus is the central atom, so 3s1, 3p3 and 5d1. So here 3O minus atom has 1 unpaired electron, so this can form 3 covalent bonds. Similarly, we have here oxygen atom, so which contain 2 unpaired electron. So it can form covalent bond with 3s orbital, and it can also form a d pi p pi bond. So that is a pi bond. So here is the structure. So here you can have 4 bond pairs and 1 pi bond. So according to the principle, pi bond does not contribute towards the structure. So in PO4 3 minus, phosphorus has undergone sp3 hybridization. So phosphorus has 4 bond pairs and double bond is not counted. So the geometry would be tetrahedral. So please subscribe to our channel Chemistry Live UGPG, and this is also available in the website www.chemistryliveugpg.com. For class 11th and 12th students, this is the channel Foundation Chemistry AB. So this is a simple step towards e-learning making life better. Thank you all for learning.